Hi everyone. Now we are going to discuss about another one transistor circuit from the current transistor base to emitter voltage VBE will be equal to 778 millivolt, and here we are considering the current gain of the transistor. The beta will be 100. If you see the circuit, this is a current mirroring circuit. Before proceeding the calculation, we need to calculate about the reference current at node B. That means the current across the resistor R1. As we know that base to emitter voltage VBE will be 0.778 volt and beta will be 100. That means the base voltage of the transistor will be 0.778 volt. Here the collector and the base of the transistor Q1 will be shorted so that the voltage at the node B also 0.778 volt. If we want to calculate the current across the resistor R1, we need to apply the KCL rule at node A. As per KCL rule, current across the resistor R4, IR4 equal to IR3 plus IR1. So, current across the resistor R4, IR4 equal to 10 volt minus voltage at the node A, that is equal to VA, divided by 4 kilo ohm. And similarly, current across the resistor R3, I R3 is equal to voltage across the node A, that is VA, minus this terminal of the resistor connected to the ground, so that which is equal to 0 volt divided by 2.57 K. And similarly, current across the resistor R1, that is IR1, is equal to VA minus 0.778 volt divided by 1 kilo ohm. If we substitute this value into this equation, that is equal to 10 volt minus VA divided by 4K equal to VA minus 0 volt divided by 2.57K plus VA minus 0.778 volt divided by 1K. When we simplify this, we will get voltage at the node A, that is VA is equal to 2 volt. So that current across the resistor R1, IR1 is equal to 2 volt minus 0.778 volt divided by 1 kilo ohm, which is equal to 1.22 milliamps. That means the reference current IREF at the node B will be equal to 1.22 milliamps. This current across the resistor R1 is divided into two branches. One is in this direction and another one is in this direction. This direction current we can consider as IC, the collector current across the transistor Q1, and this current we can consider as base of the three transistor, the Q1, Q2 and Q3. The base current can be given as IC divided by beta. From this we can say that IC is equal to I rep divided by 1 plus 3 divided by beta, which is equal to 1.22 milliamps divided by 1 plus 3 divided by 100. When we simplify this, we will get 1.18 milliamps. That means collector current across the each of the transistor will be 1.18 milliamps. So that the current across the resistor R2 will be the 2 times of collector current IC. And we can consider current across the resistor R2 will be IC dash, which is equal to 2 times of IC, which is equal to 2 times of 1.18 milliamps. And when we simplify this, we will get 2.36 milliamps. So that current across the resistor R2 will be 2.36 milliamps. Then we will calculate the collector voltage. Collector voltage VC is equal to 10 volt minus IC dash times R2, which is equal to 10 volt minus 2.36 milliamps into 1 kilo ohm. When we simplify this, we will get 7.64 volt. This is the voltage across the collector. So let us simulate the circuit. When I verify the current across the resistor R1, that will be 1.22 milliamps, and similarly current across the resistor R2 will be 2.37 milliamps, and voltage across the collector will be 7.62 volt. Hope you are able to understand the current mirroring circuit and how to calculate the collector voltage, and we have studied about the Kirchhoff current law. I request you to kindly subscribe and like the video. Thank you. Thank you for the watching.